Hello everyone, welcome to happymath.com. So this time we will do testing the difference between mean with dependent samples. So last time we talked about what dependent sample means. Dependent sample means basically you are taking survey or you are experiment with the same sample basically. So look at this example, then I can confirm why this is dependent sample more clearly. A golf club manufacturer claimed that the golfers can lower their score by using the manufacturer's newly designed golf club. 8 golfers are randomly selected, and each is asked to give his or her most recent score. After using the new clubs for a month, the golfers are again asked to give their most recent score. The scores for each golfer are shown below, assuming the golf scores are normally distributed. Is there enough evidence to support the manufacturer's claim at alpha equal to 0.10? Okay. The dependent sample case, now we always find out difference between so selection 1 and the selection 2 here. So this case, our selection 1 become old score and selection 2 become new score. Okay, so center will be basically 0, which means they are equal to each other. That's our assumption here. Okay, so in this case, newer golf club lower the score, which means old score will be bigger than newer score here, right? Okay, because old score is bigger than newer score, their difference will be bigger than 0 basically. Make sense to you? Yeah, that's the reason HA become mu D. Mu D means mean difference basically will be bigger than 0, and that's our claim. And then null hypothesis become mu D, so mean difference is less than or equal to 0. Okay. Again, the reason we are setting up at 0 here because we are finding difference between category 1 to category 2 here. So this sentence I know is a little bit confusing here. So manufacturer claim that golfers can lower their score by using the new club. So which means old score must be higher than your score based on this claim here. Okay, that's the reason we set up mean difference is bigger than 0. Okay, that's our claim basically. Okay, and now we have a table here, so we will use data analysis tool of the Excel, and then let's start analyzing. Okay, now go to data and then click data analysis. Now this time you are taking t-test paired to sample for mean. Paired, so pair means dependent sample basically. So okay here. Then now this become old score, and now range 2 become variable 2 become new score. Now I also click the title, so I label. If you don't highlight the title here, then don't click label though, okay? Because I did title too, so I did a label as well. And then now, what's the alpha? Yeah, alpha 0.1. Okay, that's good. And now I want to put output range maybe around here, maybe here. Okay. And now this is our table here. Okay. And now I can see our t statistic. That's the basically sample statistic value. And then it is the one tail, right? So one tail, so I'm gonna find out one tail clinical value. And then I also want to highlight that one tail p-value. Okay, like that. So using p-value first and analyze it, this hypothesis testing. So we know that alpha equal to 0.10. Okay, then now between p-value and alpha, which value is greater? Yes, alpha is greater. So which means based on this, we can conclude reject HO, right? Okay, then let's compare our sample t statistic and then sample t critical one tail value. Okay, before we set it up, we need to know is it right tail test or left tail test? Yeah, it's beta side, so it should be right tail test. So then I can, using this number, so I'm going to just make a maybe rounding 1000 digit here. Okay, so put it here, 1.415. Based on this, right side become HA, and then left side become HO, right? And now I'm going to just highlight it too for you, so you can see better. Okay, now between these two, where this T value belongs to? It is belongs to HA area or HO area or HA area. Yeah, obviously, it is belong to, oops, sorry. So this T square is belongs to HA area, right? Because I can see 1.49826. Okay, so it's rounding 3 decimals, so we can see a little better. Okay, so 1.498 is bigger than 1.415, so it is located on the right side, which is HA area. So based on that, we can also reject HO. Okay, so now claim us on HA, we reject HO, so therefore there, I'm gonna write the outcome here. So there is enough evidence to support a claim so that your block lower down player's score. Okay, so that's our conclusion basically. All right, so that's how you do basically hyper testing with a dependent sample. All right, thank you for joining.